Love. How does it feel when you hear that word? It feels different, right? Love is the most insanely thought about thing in human history. For a non expert, it's a feeling you have for someone like you never felt before. For a psychologist, love is a behavior or action that comes with a feeling. For a doctor, it is an addiction to a person caused by hormones like oxytocin. For a mathematician, love is all about patterns. Growing up, we have experienced love stories in our life, either it is with our parents, with our partner, or with our siblings. And interestingly, the feeling is different depending on the situation we are in. I think most of us do agree to the fact that love is essential for our existence. There is a whole new world where love is not only essential to the existence, but also has a bigger purpose. I'm a chemist and I'm here today to tell you a love story that happens in the world far from our sight, the world of molecules. Sounds surprising, doesn't it? In fact, DNA, the building block of life, is a product of such a love story where two strands of molecules come together to form the structure. The love story I'm going to tell you today is not about molecules forming a permanent bond. It is about them staying together or breaking up to achieve a bigger purpose. The bond between molecules in lab is extremely sensitive to external factors. Depending on the environment they are in, the molecules in our story choose what to do. Just like a love story, there are two possible outcomes, choice between forming a bond or breaking up. Such a response to the environment can be a blessing in certain fields of medicine like drug delivery. Existing drugs in the market have a great potential in treating the disease, but they simply don't have the intelligence to differentiate between healthy and unhealthy environments. Chemists are actively searching for intelligent molecules that can bridge this gap and carry the drugs inside the body. Potential carriers should check two boxes: hold the drugs intact when they sense a healthy environment, and release the drug in an unhealthy environment, similar to how real life couples stay together in a healthy space and break up in a toxic space. In my research, I study how molecular love evolves and test the feasibility of using molecular couples as drug carriers. The key to achieving this is to develop a method where there is a clear signal that can tell us if molecules choose to stay together or to break up. In my research, I use molecules that are similar to drugs and environmental triggers to study this relationship. The triggers change the environment around the molecules and alerts them to take an immediate action. If they choose to be in a relationship, I see the outcome as a beautiful bright red color on a microscope. When they choose to break up, I see the outcome as a dark image. Based on the intensity I see on the microscope, I can be able to quantify how strong the love between the molecules is. It was observed that when the molecules are in a relationship, they tend to hold the drugs inside, whereas when they break up, they expel the drugs into outside, making them potential carriers for drugs. Love involves both joy and pain. For molecules, either of the outcomes is a win towards a bigger purpose, that is, to make the existing drugs intelligent.